Good day, everyone. It is a pleasure to be here with you wherever you may be. My name is Judith Hurwitz. I'm the Chief Causal Evangelist here at Gemino Software. Today, we will be talking about causal discovery, and we'll be discussing how Geminos is using Chat GPT to make causal discovery more transparent and easier to deal with. So with no further ado, I'd like to introduce Stuart Frost, the CEO of Geminos Software.
Thanks, Judith, and once again, welcome everyone. It's see, we've got quite an international set here, so Cyprus and Poland and New Mexico. So it's great to see you all again. So as Judith said, we're going to be talking about how we've integrated Chat GPT. It's obviously all the rage at the moment. I think we've integrated it in a very intelligent way to solve a specific set of problems within causal discovery. And we're finding it to be really quite effective when it's used in conjunction with subject matter expertise. So obviously we don't want to fall foul of the hallucination problem that is rife in tools like Chat GPT. So also we will use the phrase Chat GPT, but the reality is it's flexible. You can plug in whichever generative AI tool you want to use. So if you want to use Bard when they have an API, etc., that's okay. We're also looking at using some of the private GPT tools as well, and I'll talk about how we're going to integrate those in the next phase of development. So first of all, let's talk a little bit about causal inference and discovery, why it's important. And this is a chart from Henan's paper from a few years ago. And fundamentally, what it's about is that causal inference gives us a layer of understanding that is simply not present in traditional ML/DL approaches. So, when we just focus on pattern recognition, etc., it's simply not going to enable us to make better decisions, which is fundamentally what our customers are looking for at the end of the day. The technology underpinning it all isn't necessarily all that important. What we need is a business outcome, and that's fundamentally about making a decision. So what we feel really is somewhat, I think, missed in all the hype around causal inference is that it's fundamentally a great tool for helping businesses make better decisions. And that's what we've oriented our whole approach to. So that's kind of where we're coming from. And the important thing then is, how do we get going with all this? And of course, fundamentally, the reason why this is better is that correlation does not imply causation. And it simply doesn't provide a good basis for decision making. I mean, there's lots of silly examples out there where correlations are very, very close, but obviously not causal, and wouldn't be a good basis for making decisions. So a couple of funny examples there from the Spurious Correlations website. I particularly like the one about the films Nicolas Cage appeared in. It's very, very close, and yeah, obviously not actually causal. So we've got to avoid those. We've got to understand the problem domain, and we need help to do that. So that's what we're doing here with the Chat GPT integration. And what we're finding as we talk to customers and do more and more projects is that this idea of fundamentally causal relationships is not alien to people. I'm not just talking about data scientists here. The business users, the managers that need to make better decisions. We find that they get pretty comfortable with the whole concept of cause and effect, because it's what we as human beings have done all our lives. It's how we learn. We do things, we see what happens, we test out hypotheses effectively in our heads, and we figure out how the world works. And that's very much how we're approaching this. If we can build a good enough model of the world that we need to study and need to make better decisions in, then we can make better decisions based on that. It doesn't have to be perfect. We know there's going to be some unobserved variables, etc. But as long as we're making better decisions and getting good outcomes, good enough. So, and I think that's a little bit of a difference between what we're seeing with customers and perhaps the academic community. Whereas obviously in academia, you have to have your paper peer reviewed. It has to, pass all the tests and so on. And in business, fundamentally, make my life better, make my decisions better, help me to fix things when they break. So it's a slightly different level of scrutiny. And that's fundamentally what we're targeting. Because, it is all about making better decisions. And, what we need is a model of the world. We need to be able to ask what-if questions. We need to think about counterfactuals. How could things have been different if a variable had changed, or if I intervened to make something different? And that's, for me, the key benefit of causal inference and the way we've built it into the Causal AI platform. But the challenge is that there's a lot of barriers to entry with Causal AI, and it's a lot of complex research. You start reading the papers; it's pretty impenetrable in a lot of cases. A lot of complex formulas, etc. And to use the libraries in the raw, you've got to be a Python programmer. You've got to be a data scientist that's very familiar with causal inference, etc. And also, if you're just using the libraries, it's challenging because it's difficult with no common language between the business and the data scientists, and that's a big part of what we're looking to address with the Causal AI platform, because we need to understand what the business needs. What is the decision that they need to make? What are the key variables? And we need to capture that subject matter expertise in order to make that possible. So that's where we're coming from, with the idea of building an actual final solution that helps us run the business better. And you'll see in our next webinar that we'll talk about our Causal Digital Twin technology, which is really the kind of final outcome of this, an application where the causal model is built into it, that will monitor data in real time coming from a business process or manufacturing process, whatever it is, and help you to understand when things are going wrong, what's causing them, and more importantly, how to fix them, what to do about it. So this kind of end-to-end aspect of the platform is extremely important. So we'll be talking more about that over the next few weeks as we flesh that out. So that's the kind of fundamental goal. How do we bridge that? And that's what we're looking to do with Gemma's Causal AI. So what we've done is built a platform that helps you capture all this knowledge of the organization in different ways. We've built in all the libraries that you will need to make that all possible. It's just a limited set at the bottom. There's lots of other things that we've built in too. But very important, I think, to understand that, our goal here is to help businesses make better decisions, and the whole methodology that's built into the tool is oriented around that. And we view Chat GPT as really a key tool in that context. It's a slightly different view of our world and what the platform does. As I mentioned, we've got this really end-to-end approach. It's got its own repository built in using a graph database. It's all based on Node-RED, which is a low-code development platform. We've extended it to really allow the building of causal and knowledge models very easily, very accessibly to a business audience. We can then populate those models with data using ETL. We've got the ability to pull in data from many, many sources, thousands of sources, using both Node-RED and our own proprietary capabilities to bring data in. I'll come back to the causal discovery because that's the key part of this webinar. We can do model analysis using PyY. We can plug straight into Jupyter so that you can extend the models, etc., if you wish, in a very familiar environment. And as I mentioned earlier, we're going to end up with the Causal Digital Twin. But coming back to causal discovery, we've seen this as really one of the initial barriers that people hit. Great, I'm sitting in front of this tool. I can draw a model. How do I go about it? How do I get started? And it's actually, once you get going and overcome that barrier, we're finding it to be relatively straightforward and accessible, but there is that initial hesitance. So one of the things that we're increasingly doing now is building more and more tools into the platform to help with that problem, with obviously Chat GPT being one of the primary ones. So how does this all start to string together? We see this as very much as an iterative, interactive process. Subject matter experts bringing in their experience, training insights, leveraging the GPT-4 based assistant that we've built in. So you can ask research questions, you can get, as you'll see in the demo, models directly built for you by the GPT interface. And then obviously what we've got to do is test those potential relationships. So we've got to figure out, have we missed something? Is there something in there that doesn't make a lot of sense? So perhaps the GPT hallucination problem, or simply perhaps it's that we don't have the data for it. So right now it's going to be unobserved, and we've got to figure out whether that's too much of an impact on the model and leading to poor results. Then combining that with more traditional causal discovery tools like those in PyY, so we can take in data sets and we can test the model, we can figure out what's missing, etc. And then we'll be going on in the next phase of development to incorporate some other private GPT tools so that you can look at your own corporate data, including metadata, etc. And I just want to emphasize that we found that GPT is remarkably good at discovering causal relationships. It's not perfect, none of these tools are, but it is much better than we would have expected. And of course, that's a little bit of a puzzle because it certainly doesn't understand causal relationships, but it does a pretty good job of surfacing them in multiple domains. So as an assistant, it's really quite effective, more than perhaps we would have expected. And our friends at Microsoft Research have published a nice paper on this, explaining what's going on and why and how to use it. So we've incorporated a lot of their research as well and their approaches and so on into this as we go forwards. So it really overall creates, I think, a more accessible approach to getting started with causal modeling, and does help quite a bit more than we would have perhaps expected. And of course, the other nice thing from our point of view is that GPT is continuing to be developed. There's a lot of competition in there. There's a lot of different versions coming through, GPT-5 probably by the end of the year, and they're just getting better and better. So it's a kind of fascinating area of technology, and we're very happy to be able to leverage it and solve some of these key problems in causal discovery. I want to switch now to just show you a short demo, about 10 minutes, and then we'll take Q&A after this. So I'm going to hand it over to Virtual Owen, who's our senior analyst on this and helping customers to build models. And I'll come back after we've watched the video.
Hi, this is Owen from Geminos, and today I'm going to be giving you a quick overview of the GPT integration for our Causeway platform. A question we get asked a lot by our customers is, how do we get started with causal models? And how do we know if the models we have built are good enough? The GPT integration, alongside our other analysis tools, helps our users to answer these questions. When we're building a causal model for a specific problem, we're trying to answer a research question and make better decisions around it. The research question that we're going to be asking in this example is, what causes aircraft turbines to fail? And if we can answer this, then we can prevent future turbine failures by making the right maintenance decisions. A typical GPT response to this type of question involves a long list of variables, and it's then up to the user to draw causal relationships between these variables to form a model. With Geminos Causeway's GPT integration, users can go from question to model much more quickly, giving a solid starting point to build upon. Before we get started with GPT, let's do a quick reminder on what a causal model is. This is a very simple example of a causal model drawn inside Geminos Causeway. Each node in this model represents a variable, and the wires between them indicate causal relationships. The arrows indicate the direction of the relationship. So for this model, weather has a causal effect on ice cream sales. Another way of saying this is that when the weather changes, ice cream sales will change. Causal models are the core concept behind our platform, and the first step we take on most of our customer projects is helping them to build a model for their problems. Let's take a look at GPT in action inside Geminos Causeway. As we mentioned before, the research question that we're interested in is centered around turbine failure. And once we have a causal model, we're going to combine this with some publicly available data from NASA in order to do some analysis. After entering the research question, generating a prompt, and discovering relations, the causal model is added directly to the canvas. It's worth stressing that the relationships produced by GPT should be validated with subject matter experts. Anyone familiar with GPT will know that it can get things wrong, so this is a key step of the model creation phase. Most of the relationships listed here seem worth adding to the model, which can be done with the click of a button. Before we take a look at the data we used for this example, let's run through some other important aspects of using GPT to build causal models. GPT can build models from just a research question, or can be given an existing causal model and build on top of it. The models that GPT produces are intended to be used as a starting point and should be supplemented with subject matter expertise, or our analysis tools can also help with validation if domain knowledge is limited. The applicability of GPT will depend on the specific use case, but we have tested its use over a wide variety of industries with good results. Once we're happy with our model, at least for a first iteration, we can take it forward for some analysis. The causal model produced serves as a blueprint for our data requirements, since each variable in our model needs to be backed up by data. We mentioned earlier that we're going to be using some publicly available turbine data from NASA. This dataset describes hundreds of engines fitted with dozens of sensors for key components leading up to failure. We don't necessarily have data for every variable in our model, so we might need to make some changes to the model to reflect this, but our analysis can still provide insight into what causes engine failure. Based on the columns of data provided to us, we can remove some variables from our model, while bearing in mind that they still will have an effect on our outcome. Additionally, we can see from the data and a diagram of the engine that there are multiple components that may cause turbine failure, so we can add those to the model as well. The dataset primarily focuses on two specific parts of the engine, the low-pressure turbine and the high-pressure turbine, which are also known as the LPT and HPT. The wear of both of these components are tracked by key performance measurements that continuously degrade over the course of a specific engine's lifespan. Finally, the outcome provided in the dataset is remaining lifespan, or the number of days before failure. So let's make that change too. Aircraft turbines are highly complex, but the general concepts between variables and relationships in this model could be transferred to the failure of many different types of equipment. This analysis will provide a much deeper insight into what causes equipment to fail, which is important when trying to devise a maintenance policy. The results produced in this example can be used to improve decision-making with regards to timing, frequency, and extent of maintenance performed on gas turbines. As a side note, we are also currently developing a similar use case for the IT infrastructure industry, with the goal of minimizing downtime caused by component failure. Now let's take a closer look at some of the analysis results. The model and dataset that we have will serve as input to the PyY causal library, which is embedded directly inside of Causeway. Our goal is to make causal analysis features more accessible to a business audience. By double-clicking on a node, we can dig into the causal relationships that a specific variable is involved in. We can see how each form of wear affects the remaining lifespan of a turbine relative to one another in a straightforward manner by inspecting the edge strengths. These results shown here imply that HPT wear has a stronger relationship with remaining lifespan, and that this component is more likely to cause a failure. Intrinsic effects allow us to go into even more detail. While edge strengths only consider parent-child relationships, intrinsic effects include grandparents, great-grandparents, and so on. We can see that the operating pressure and usage of the turbine also have a noticeable impact on remaining lifespan. which is consistent with the response that GPT produced. Another element of the intrinsic effect shown here is the level of noise for a given variable. This can be seen at the top of this chart, labeled remaining lifespan. This noise is a measure of how well the causal library is fitting its functions to the data provided. If this noise level is too high relative to the other strengths, then this suggests that there are one or more unobserved variables in our model. In this case, other parts of the turbine are likely to be causing failures, and further sensor data should be gathered and added to the analysis. Another likely cause of this noise is the variables that we didn't have data for and removed from the model earlier. Whether a certain level of noise is acceptable or not is up to the user, and models with high noise levels may still prove to be useful for improving decision-making. On the other end of the spectrum, we might see variables that have a particularly low effect. In some cases, this is to be expected, such as initial wear. However, sometimes these low effects are not consistent with our domain knowledge, which again implies that there are either some unobserved variables or inaccurate relationships in our model. These are all tools that Causeway provides to help users understand if their model is accurate enough in order to make a difference in making decisions. We can also take a look at all of these causal effects on our original causal model. These edge strengths are consistent with our understanding of the domain. Where for both components has a negative causal relationship with remaining lifespan. Another way of saying this would be that when wear increases, lifespan decreases. Why is all of this important? For this example, we could expand the model so that turbine failure feeds into a broader policy for maintenance, taking into account variables such as length and cost of downtime caused by failures. The analysis produced in this example could be used to improve decision-making with regards to timing, frequency, and extent of maintenance performed on turbines or other pieces of equipment. This is usually delivered in the form of a Causal AI application, which is fully buildable inside of Geminos Causeway. The model and data analyzed would drive recommendations for maintenance and help engineers to decide when to replace key components. This was a quick overview of how our users can use GPT to help build causal models for their problems. If you're interested in learning about the platform in more detail, visit our website or scan the QR code. We hope you found this demo useful, and thank you for watching. Hi, this is Owen from Gemma.
Apologize. So, yeah, if you want to get more information, you can certainly scan the QR code. I just want to point out, obviously that's quite a simple example, but what we wanted to do was just show in a 10 to 15-minute video that the iteration process, that you can ask GPT, you can get a basic model out, and you can start to ask questions, which is fundamentally what this is all about, right? How do we go through in a structured way and test our hypotheses so that we've got a more scientific approach to building these systems, and obviously underpinned by the causal math and the causal science. And we think collectively this approach gives us a much better chance of getting good outcomes. So that's what that's all about. With that, I will reintroduce Judith and see if there are any questions.
Thanks, Stuart. And we do have a number of questions. Let's start with the first one, which is, can Chat GPT integration be used to fine-tune causal models? Can it be used iteratively, or is it just for the initial model build? Great question.
Yeah, absolutely. No, the idea is, from our point of view, to build it in throughout the life cycle, so that yes, you can start out with a blank screen, but you can also feed it an existing model. So I think actually, does this one do that? I don't think this specific example did that, but you can actually feed it a model, and what it does is give it to Chat GPT in a structured format, and then get additions to it that you can select or deny or whatever. But we're also going to go further than that, and as I mentioned earlier, start to build in things like private GPT, so that you can actually go through things like existing corporate documents, and also things like logs, So obviously in these kind of situations where we're interested in doing predictive maintenance or prescriptive maintenance, you want to actually include the engineer's notes, the logs, the support tickets, whatever they are. So we want to be able to actually build those in and include those as part of the data and part of the causal discovery. So we're going to start building that in too. And then also further down the line, build it into the Causal Digital Twins so that when there's a problem, it will actually assist you in understanding what is going on. Kind of again, an assistant that wraps itself around the model and the data to help you understand common scenarios, that kind of thing. So we are planning to build in the generative AI technology really throughout the life cycle.
So the next question is, how do you verify the causal variables identified by Chat GPT when you may not have access to empirical data?
Well, of course, this is fundamental to causal discovery, right? What we're getting from GPT or our own subject matter expertise is a hypothesis about what variables might be causal and in what way. And we've got to test those hypotheses. And if we don't have data for them, then we might synthesize some data if we at least understand the patterns and the behavior in that data. Perhaps we can synthesize it. Perhaps also we can then have a roadmap to gather that data in the future. We might have to invest in more sensors if it's an IoT type situation. We might have to go find a public data set or something like that. So in the video, Owen mentioned that you've really got to drill in and assess whether there's too much noise in the model and whether the model is useful in terms of making better decisions. And if you find that it isn't, then you've got to decide what to do about it. And you've got to decide whether you're going to add more data to the model or simplify it or whatever. It's all part of the process. But I guess to my mind, unless we go through that process and test those hypotheses, we're just, we're obviously going to struggle to get good results. And I think it's just a much better way of thinking about building these solutions than traditional AI, where basically what we're going to do is take all the data that we happen to have lying around and do some feature engineering and throw that as an algorithm. Perhaps not the most scientific approach to solving these problems. So it's fundamental to the whole causal discovery and causal methodology, I think, that we work through and ask the questions. And that fundamentally is what science is all about, right? Set some hypotheses, ask questions about it, test them. See what you think, make improvements until it's good enough.
So our next question is, are there any constraints on causal model size?
Not fundamentally that I'm aware of. We can certainly build pretty significant models. And also what we typically end up doing is building a sequence of causal models to, effectively answer smaller questions. Like, for example, in this gas turbine example, clearly some of the variables have other causal models behind them, right? They don't just appear out of nowhere. So some of the things like the environmental variables and the usage, well, that's going to be down to things like where the plane is flying. Is it flying in a situation where there's a lot of sand ingestion? Perhaps it's flying out of a desert relatively often, or it's by an ocean, so there's more salt ingestion. So we can start to work our way back through that and build other causal models that feed into it. And that's all possible within the Causeway platform. There's no real limitation on scale that I'm aware of in that.
Next question, is there a non-GUI version of feeding in the data and returning results via the API?
It's an interesting question. So certainly, the repository and everything is open. You can query it, so you can get the model structure, etc., if you wanted to. So I guess the answer to that is yes. So yeah, I think the answer to that is yes, but I can maybe check that with the development team.
Neil Radin has a comment here. There's a difference between a digital twin and simulation models, which has been used for decades and may be used for the same type of sensor data, though not always. But simulations generally generate and manipulate data as part of the simulation. The whole point of simulation is to project what can happen, not what is happening at the moment. Digital twin is useful for alerting what is happening now. Any comments on that, Stuart?
Yeah, it's an interesting point, and we have struggled a little bit in choosing the right terminology for that part of the platform. Quite honestly, it's still a work in progress, to be honest, Neil. I think in some ways, what I would say is that causal modeling and then the causal digital twin approach that we're talking about in some ways bridges the gap or crosses that boundary between simulation and digital twins. So in some ways, what we're doing when we're building the model is a simulation, and then we're deploying that as a digital twin. Now, I want to make it clear that we're not talking about digital twins in quite the usual sense. That's why we're talking about these causal digital twins. And we see the technology that we're building as very complementary to more traditional digital twins, which are really quite a software model of a thing in great detail and more the physical relationships between things, etc. But part of the challenge is that they don't have the causal math built in. So we see really an opportunity to fill that gap and add considerable value to that field. But you're right, yes, it's bridging that gap between simulation and digital twins.
So we have a question, somebody who joined a few minutes late, but his question is, are you using causal models to make Chat GPT safer or help people verify outcomes from LLMs?
Right. But we're not really directly targeting that today. I think effectively building in causal understanding to GPT and other LLMs is certainly outside the scope of what we're trying to achieve at the moment. But clearly there is a path. Once we start to understand better how well GPT understands causal models and cause and effect structures and how it doesn't, then there will be an opportunity, I think, to perhaps build some of that approach and understanding into it. But I would say at the moment, that's out of scope of what we're doing.
Okay.
So,
yeah.
question from Azamat there. So that's it. Okay. So yeah. So Azamat's questioning the responsible / trustworthy AI credentials of GPT, which is fair. I want to make, obviously what we're doing here is we're not just relying on GPT to build as a model, right? I want to be very clear on that. It's an assistant to a subject matter expert. There are problems with hallucination, etc., but that's why we've got to test it. But we've got to test our assumptions anyway. So whether they come from a subject matter expert or from traditional causal discovery on data, we can't take anything as 100% valid. We have to question everything. And that's part of the whole scientific method for discovering those kind of things. So we're just viewing it as an assistant. I want to make that very clear. We find it as a very useful tool. In most cases, actually, it seems to do a better job than the more traditional causal discovery tools, which are focused more on the data itself. Obviously, that's a rapidly evolving area of technology as well. So we're tracking all of these things and really trying to bring them together into a much more usable and accessible workbench. We don't think any one of these tools is in itself good enough today, but collectively, we think there's some significant breakthroughs there.
Next question, does GPT integration speed up causal modeling? How long does it take to build a causal model typically?
Well, clearly that's, it depends on the complexity of the problem, right? We are finding that people coming from a more business analyst side, can get up to speed relatively quickly. It's not a matter of, months, years, whatever, especially with the augmented tools of things like GPT built in, etc., that we're offering now. We are finding that people can get up to speed pretty quickly. I know, for example, that Owen built the model for the gas turbine, relatively simple one, but nonetheless, a meaningful model. That was just a few days. That's not a huge amount of work. Yeah, I think it does depend very much on the complexity. In most cases, it's weeks, not months or years.
So we have a question. Your GPT prompt looks rather simplistic. I'm wondering if you can share a catalog of prompts that can lead to a more realistic DAG.
Yeah, what we'll be doing over the next few weeks is publishing a series of videos that ask more complex research questions. Obviously, in the example given, we just wanted to give a general high-level overview. So I'd encourage you to track the website and look for more information as we go forwards.
Okay. And then question is, do you submit the causal model into Chat GPT together with the prompt?
So yes, if you have an existing causal model, it will submit it in and ask for extensions to it.
Okay, you have focused so far on industrial type of use cases, supply chain, etc. Are there any industries that causal analysis is more difficult to model or less useful? What are the reasons for this?
Interesting question. I would say in general that the bulk of the problems that we're helping customers solve at the moment are some form of either predictive maintenance, prescriptive maintenance, or they're help me understand outlier performance with my customers. For example, in a 5G network, right, there might be certain customers that require very low latency. There might be others that want high bandwidth. There might be some others that want to balance. And what they want is to make sure their SLAs are being met in all those cases. If you're a network operator, you've got to meet the SLAs. So what are all the trade-offs? Why are people seeing outlier performance? And I would say that's a common pattern of the kind of decisions that customers are looking to make using the platform. And that's obviously applicable to a lot of different industries. So, farm machinery is one customer, another is, manufacturing process. We're also getting a lot of traction in AI ops for IT management, as I mentioned, telecoms with 5G networks and that kind of thing. And there's a common pattern there, obviously very different data and very different causal structures, but nonetheless similar. So I would say that's generally the area that we're getting more and more traction and a lot more interest, and the kinds of use cases that we are orienting the platform around. But we're also getting interest in healthcare and some financial services, etc. So but yeah, on the whole, manufacturing, IT, telecoms, those kind of areas.
So Neil Radin has a clarification on his earlier point on digital twins. He says, to clarify, I don't see how digital twin can function without a causal model. Most of the ones I see are rules-based, which is not good enough. So I like your approach. Thank you, Neil.
Yeah, thanks, Neil. You're absolutely right. I think let's face it, this, the causal inference and causal modeling, etc., and the math underpinning it is relatively new. And I'm obviously certainly one of the believers in this, and think that it's just so much easier and so much more practical to build these kind of solutions when it's underpinned by a more scientific approach. So yeah, I think it's going to be a major benefit to the general digital twin market. But as I said, we've got to just be careful to define our niche very carefully and make sure that people understand that what we're complementary to, and that we're not trying to replace general digital twins.
Right. Well, at this point, we don't seem to have any more questions. If you do have questions that you didn't have a chance to answer, please feel free to reach out to us. It's been a pleasure joining with you today. As a little advertisement, myself, Judith, and John Thompson have completed a new book on basically the business side of Causal AI, which will be coming out in the very end of September. So hopefully you'll look for that as it comes out. And I'd like to thank everyone for your participation and look forward to having you join us next month for our next webinar. And if you have friends and family who would like to listen to the replay, that will be available shortly. So thank you so much and have a great day.
Thanks, Judith, and goodbye, everyone.